How they built the world's tallest statue, and why. An epic tale of ambition, engineering, and legacy. The genesis of a monumental dream. The story of the world's tallest statue begins not with steel and concrete, but with an idea powerful enough to move mountains, or in this case, to erect one. In the early 2000s, as nations across the globe competed to create ever more impressive architectural wonders, a bold vision took shape in the minds of a country's leaders and cultural architects. This would not be just another statue. It would be a statement carved in bronze and stone, a declaration to the world that this nation had arrived on the global stage as a force to be reckoned with. The chosen subject was no random historical figure, but a beloved national icon whose life and teachings had shaped the country's identity. The selection process itself was a study in national psychology, months of deliberation, public surveys, and heated debates among historians and politicians. Would it be a warrior king from ancient times, a spiritual leader whose philosophy endured centuries, or perhaps a modern unifying figure who led the nation to independence? The final choice reflected not just historical significance, but contemporary political currents and the nation's desired image on the world stage. Blueprints of the impossible. Designing a titan with the subject chosen, the real challenge began. How to translate this vision into physical reality. The design team, comprising the nation's top architects and international engineering consultants, faced a paradox. The statue needed to appear graceful and inspiring while being structurally capable of withstanding forces that would destroy lesser constructions. The initial sketches went through hundreds of iterations. Early concepts showed the figure in dynamic poses, arm raised in blessing, or striding forward, but these were rejected as too unstable at such scale. The final pose represented a careful compromise between artistic vision and engineering necessity. A dignified, stable stance that could withstand high winds while still conveying power and benevolence. Computer modeling revealed nightmare scenarios engineers had to solve. Wind vortices creating dangerous oscillations at certain altitudes, thermal expansion causing metal panels to warp and buckle, differential settling of the massive foundation potentially twisting the entire structure, lightning strike probabilities, approaching certainty at such heights. The solution was a radical rethinking of traditional statue engineering. Instead of a solid core, the internal structure would be a hollow lattice of reinforced steel, carefully tuned to absorb and dissipate energy. The outer bronze skin would consist of thousands of individually cast panels, each with precisely calculated expansion joints. The foundation would employ techniques borrowed from offshore oil platforms and nuclear power plants, deep pilings reaching down to bedrock, with sophisticated damping systems to counteract seismic activity. The foundation, building on shifting sands of reality, groundbreaking ceremonies made for excellent photo opportunities, but the real work began unseen, deep underground. The foundation team faced geological reports that read like horror stories, layers of unstable sediment, underground water channels, and worrying seismic activity forecasts. The solution was a foundation so massive, it defied comprehension. Over 50,000 cubic meters of high-grade concrete steel reinforcement bars totaling enough length to circle the equator, a network of sensors monitoring pressure and movement at 200 different points. Earthquake dampers adapted from technology used in Tokyo's tallest skyscrapers. Workers labored in 3 shifts around the clock, battling monsoon rains that turned excavation sites into muddy quagmires and summer heat that made the steel reinforcements too hot to touch. The concrete pours required military precision. Any pause in delivery could create weak points where layers failed to bond properly. On the largest single pour, a convoy of 150 concrete trucks rolled in continuous procession for 36 straight hours. Rising steel, the skeleton takes shape. As the foundation cured, a process carefully monitored by ultrasound and thermal imaging. Attention turned skyward. The steel framework rose in sections, each requiring millimeter-perfect alignment. The erection process resembled a bizarre hybrid of bridge building and ballet. 100-ton cranes leased from international heavy-lift specialists, laser alignment systems accurate to 0.1 millimeter over 100 meters, teams of sky welders working in suspended platforms hundreds of feet in the air, real-time wind monitoring that could halt work at a moment's notice. The steel itself was a custom alloy, developed specifically for this project. Traditional structural steel would have been too heavy at these heights, while lighter alloys lacked the necessary strength. The solution came from aerospace technology, a titanium-enhanced steel that maintained strength while shaving critical tons from the overall weight. The skin of a giant, bronze alchemy. At scale, while the skeleton grew, foundries across the country worked feverishly on the statue's outer skin. The bronze cladding presented challenges that hadn't been faced since ancient times, just vastly magnified. Traditional sandcasting methods couldn't maintain consistency at this scale. The alloy composition had to balance durability, color retention, and workability. Each panel's thickness varied based on its position and expected wind loads. The solution was a combination of ancient craftsmanship and cutting-edge technology. Master metalworkers from traditional bronze casting families collaborated with materials scientists to develop new techniques. Robotic arms assisted in the precision pouring of molten metal, while artisans hand-finished each piece to ensure perfect surface quality. The patina, the statue's final color, became a subject of intense debate. Accelerated aging tests simulated decades of weathering in months, showing how different alloy mixes would change over time. The selected formula would mature from its initial bright bronze to a dignified, slightly greenish hue within 5 years of exposure. The eyes of the world, installation, and final assembly. As the first bronze panels began their ascent to their permanent positions, the project entered its most visually dramatic phase. Each piece had to be precisely aligned, using GPS-guided positioning systems, secured with custom-designed expansion joints, sealed against moisture intrusion with space age, polymers electrically grounded to prevent lightning damage. The face, always the most scrutinized part of any statue, required particular care. Cast in just 3 massive sections, unprecedented in bronze casting, its assembly had to be flawless. When the final piece was lowered into place, held by cables so fine they were nearly invisible, the sight fell silent. Then, as the sun broke through the clouds, illuminating the completed visage for the first time, spontaneous applause broke out among the hundreds of workers present. Controversy and criticism, the price of ambition. Even as construction progressed, the statue became a lightning rod for debate. Economists calculated that the total cost could have built the modern hospitals, 300 schools, clean water systems for every remote village in the country, or funded a decade of scientific research grants. Environmentalists pointed to the ecological cost, thousands of tons of mined metals, the carbon footprint of continuous concrete production, and disruption to local wildlife habitats. Political opponents framed it as a vanity project, a distraction from pressing social issues. Supporters countered with projections of increased tourism, job creation, and intangible benefits to national prestige. They argued that great civilizations are remembered not for their spreadsheets, but for their monuments, and that this statue would pay dividends for generations in both economic and cultural capital. The unveiling. A nation holds its breath on. Inauguration Day, the world's media descended on the site. Security teams managed crowds numbering in the hundreds of thousands. The ceremony blended ancient traditions with modern spectacle. Religious leaders offered blessings according to multiple faiths. Military honor guards performed precision drills. Children's choirs sang a specially commissioned anthem. Dignitaries from dozens of nations looked on. When the shrouds finally fell away, revealing the completed colossus in the golden light of late afternoon, the reaction was visceral. Some wept openly, others stood in silent awe. Camera shutters clicked like mechanical crickets as the first official images flashed around the globe via satellite. Engineering triumphs, by the numbers, total height, 600 meters, including pedestal. Weight, over 40,000 metric tons bronze used, enough to cast 5,000 life-sized statues. Construction time, 5 years, 2 years ahead of initial estimates. Workforce, peak of 3,500 workers simultaneously on site. Safety record, 0.78 accidents per 200,000 work hours, industry-leading. The future, preservation and evolution. Now complete, the statue faces new challenges. Ongoing maintenance against weathering and pollution effects. Developing tourist infrastructure to handle millions of annual visitors. Protecting against potential security threats. Managing the surrounding area's development. To prevent visual pollution, conservators are already planning for centuries of preservation, using lessons from ancient monuments that have survived millennia. Advanced coatings that self-clean in sunlight, AI-assisted structural monitoring systems, and sacrificial anode corrosion protection all play roles in this long-term strategy.